Hi everyone. This lecture is part of BSN Generic Biostatistics course. Today we will learn how to analyze paired data using SPSS with clinical example. We are given a real clinical scenario. A distributor claims that the nutrition meal replacement helps overweight individuals lose weight within 1 month. To test this claim, weights of 10 individuals are recorded before treatment and after treatment. Our goal is to determine whether there is a significant change in weight. Before applying the paired t-test, we must check assumptions. Data should be continuous, observation must be paired, differences should be normally distributed, variances are unknown. If these assumptions are satisfied, we can proceed with the test. We will follow 6 steps of hypothesis testing. Statement of hypothesis is the first step. Second step is level of significance. Third step, test statistics. In this step, we decide the test. Fourth step, decision rule. Fifth step is computation using SPSS software. Sixth step, results and conclusion. Before performing the peer t-test, we check normality of the differences data using the Shapiro-Wilk test. Null hypothesis data follows the normal distribution and alternative hypothesis data does not follow the normal distribution. Decision rule. If p-value is less than 0.05, we reject normality assumption. First, we open our data SPSS file. In data editor, we go variable view and create our 3 variables: serial number, before before weight, and after, using the nutritional replacement weight. In second, then we go to the data editor and enter our data before weights and after weights. The first step, we compute the variables difference variable. Go to transform, compute variable. In compute variable window, first we move the weight before and press the minus sign, and then move the afterwards. The target variable name is differences. Press OK button. In this dataset, our third difference variable show. For test the normality assumption, we go to Analyze, Descriptive Statistics, and Explore. In Explore window, we move difference variable independently and press the Plots button. Explore plot button. We check the normality plots with test and press Continuous and OK button. The p-value is 0.51, which is greater than 0.05, so we fail to reject the null hypothesis. This means the data is normally distributed and we can proceed with paired t-test. Here conclusion is our p-value is greater than 0.05, which is 0.851, so we fail to reject H0 and conclude that the differences of data follows the normal distribution. Paired sample t-test. First, we make the hypothesis statement. The null hypothesis is there is a no change in weight after getting nutritional meal. There is a change is alternative hypothesis. Level of significance 0.05. Test statistics. We use paired sample t-test, and critical region, we reject our H0 if our p-value is less than 0.05, otherwise not, fail to reject. H naught. To test the paired sample t-test, we go to Analyze, Compare Means, and Paired Sample t-test option. In paired test window, we move our before and after weight variables and press OK button. The results of these tests show the t-value 11.801 and the p-value is 0.000. Conclusion, our p-value is less than 0.05, which is 0.001 less than. So we reject our H naught and conclude that there is a change in weight after getting nutritional meal. Second example, question 2. An intervention is applied for 10 patients. The following data shows the measurement of fruit intake per week before and after the intervention. Test the hypothesis that the mean measurement of fruit intake are different from each other. Write proper 6 steps of hypothesis testing and check also the assumption of the test. Please also report the results in tabular form. We have 10 observations before and after. First, we check the normality assumption. The statement of hypothesis differences data follow normal distribution. Difference data do not follow the normal distribution is alternative hypothesis. Level of significance is 0.05. Test statistics we use Shapiro-Wilks test. Critical region we reject our H naught if our p-value is 0.05. Otherwise not fail to reject. First, we create our three variables in variable view. Measurement of fruit intake per week before the intervention and after intervention. Measurement of fruit intake per week after the intervention. Then we go to data editor and data view. In data view, we enter our data before intervention and after intervention. In SPSS, go to Analyze, Compare Means, Pair Sample T-test, select before and after variables, click OK for compute a difference variable. Our difference variable show the first difference is 2.3 and the last difference is 3.5. To check the normality assumption, the SPSS step is Analyze Descriptive Statistics and go to Explore. In Explore window, we move our difference variable and press the plot button, and in plot button we check the normality plot with test and press continue button and press OK. Our normality test result is 0.226 significance value, which is insignificant. Our conclusion is our p-value is greater than 0.05, which is 0.226. So we fail to reject our H naught and conclude that the difference of data follows the normal distribution. Then we check the paired sample t-test. The hypothesis, the null hypothesis is the mean measurement of the fruit intake are not different from each other after intervention. The mean measurement of fruit intake are different from each other after intervention is the alternative hypothesis. Our level of significance is 0.05. Test statistics is paired sample t-test. Critical region we reject our H naught if our p-value is less than 0.05, otherwise not, fail to reject. SPSS steps for test the paired sample t-test. Go to Analyze, Compare Means and Paired Sample t-test. In Paired Sample t-test window, we move our before and after intervention variables and press OK button. We conclude that the intervention significantly increase fruit intake. Our p-value is 0.001. Conclusion: our p-value is less than 0.05, which is 0.01. So we reject our H naught and conclude that the mean measurement of fruit intake are different from each other after intervention. Thank you for watching this lecture. If you found it helpful, like, share, and subscribe for more biostatistics tutorials.
Please subscribe and like our channel and press bell icon for more videos.